Hello students. Welcome to our Senior Secondary School 2 Physics lesson. Today, we will be learning about wave motion. But before we proceed, let's quickly recap what we learned in our previous lesson. In our previous lesson, we solved some example problems on gas laws. And we also explored the applications of gas laws. Before we begin today's lesson, let's take a quick rundown of our lesson objectives. By the end of today's lesson, you will be able to understand what a wave is and explore the types of waves. Are you ready? Let's dive in. A wave is a disturbance that transfers energy from one point to another without the permanent displacement of particles. For example, when you throw a stone into a pond, ripples spread outward in circular patterns. These ripples are waves carrying energy across the water. But the water itself does not move with the wave. It only oscillates up and down. This illustrates how waves transfer energy without transporting matter. Types of waves. There are two major types of waves, based on their nature and how they propagate through a medium. 1. Mechanical waves. Mechanical waves require a medium to travel and cannot propagate through a vacuum, such as water waves and sound waves. 2. Electromagnetic waves. Electromagnetic waves do not require a medium and can travel through a vacuum. They consist of oscillating electric and magnetic fields. They travel through empty space at the same speed. Examples are light waves, radio waves, microwaves, infrared radiation, ultraviolet rays, and X-rays. To explain further, not all waves require a medium to carry them. Light, radiant heat, and radio waves appear not to require any medium to move. For example, light from the sun reaches us after passing through a vacuum. If light requires a medium to carry it, then light from sun will not be able to reach us. Now, wave motion is the transfer of energy through a medium or space, without the permanent movement of matter. It is simply the movement of these disturbances, through a medium or space. Wave motion happens when a disturbance moves through a medium, making particles vibrate back and forth around their normal positions. Waves are further classified into two different types, transverse and longitudinal waves. 1. Transverse waves. Transverse waves are waves in which the particles of the medium move perpendicular to the direction of wave propagation. This is simply a wave where particles move up and down to the wave's direction. Key features of transverse waves. The wave moves forward, but the particles move up and down. It consists of crests, high points, and trough, low points. The region of maximum upward displacement is called crest, and the region of downward maximum displacement is called trough. It can be reflected, refracted, and diffracted. Examples: water waves. The water moves up and down, while the wave moves forward. Light waves. A type of electromagnetic wave that moves without a medium. And waves generated by plucking a string. 2. Longitudinal wave. This is a wave where particles of the medium move parallel to the direction of wave propagation. This is simply a wave where particles move back and forth to the wave's direction. Examples: sound wave. When you speak or clap, air particles vibrate back and forth. Seismic P waves. The first waves detected during an earthquake. Key features of longitudinal wave. Compression, particles are close together. Rarefaction, particles are spread apart. It travels through solids, liquids, and gases. Now, let's talk about wave properties. Waves exhibit various characteristics that determine their behavior. And they are: amplitude, the maximum displacement of particles from their equilibrium position. It is measured in meters. Period. time taken for one complete cycle of the wave. It is measured in seconds and given by t equals 1 over f. Frequency. Number of wave cycles passing a point per second, measured in hertz. Wavelength. Distance between two successive crests or troughs in transverse waves or compressions in longitudinal waves. It is the distance covered by the wave after one complete cycle. It is measured in meters. Wave speed. The speed at which the wave travels in 1 second, it is measured in meters per second. Wave motion is fundamental in physics, playing a crucial role in communication, energy transfer, and various natural phenomena. Understanding different types of waves and their properties helps in scientific advancements and technological applications. Now it's your turn. Here are 2 quick practice problems. Give them a shot. Remember to pause the screen and solve the problem. You made it to the end of this lesson, well done. Let's recap what we have learned. A wave is a disturbance through a medium that carries energy from one point to another. The 2 major classes of waves are mechanical and electromagnetic waves. Waves are transverse or longitudinal. In our next lesson, we will be learning about light waves. Well done on completing this lesson. Remember, every step you take brings you closer to your best version.